checkers. Okay, simple checkers are intended to verify behaviors that are typical to many designs. That's clear, right? Okay, thus the checkers must be reusable in various contexts, either instantiated directly in the DUT or bound using bind statement. We have discussed that bind and inlined things, right? Either we can inline our assertions in our design, or we can bind using bind statement. It is not expected that these checkers will appear in a test bench program. So these kind of things are our intention is to not implement with the test bench, right? Actually it's intended for design. Instead, these checkers may be partially associated with module or an interface, and that too we can put all these assertions in an interface, and we can reuse it across many design, right? Each checker may contain auxiliary state variables, cover statements and or cover groups, and of course one or more assert statements. So look at that. In that point, what they are trying to say means each checker will consist of cover or cover group, and then assert, and then some auxiliary state variables. Okay, both assertions and coverage can be globally controlled on an individual checker or a whole design sub hierarchy. Getting this one? Yeah, all assertions and coverage can be globally controlled, okay, by using individual checker, what we defined in VMM checker library. Reporting of any errors of assertion failures may also be done using message service. We have seen some message services in VMM VMM checker library, right? What is that? VMM log, VMM env, like that. We have seen some message interface service, right? So by using that also we can display our assertion failure messages. Next, 53rd rule. What is this? Checkers shall be packaged using an interface. This is clear, right? Interfaces can be instantiated in either module or an interface or a program. You know that in interface the main functionality, main intention or main use of interfaces, we can use or we can instantiate in across modules and modules and programs, right? It will reduce the reader, it will increase the readability, we can say in that way. Okay, next, rule number 54. The inclusion of assert property statements in the checker shall be controlled by the macro assert on. While we discuss about OVL assertions itself, we have seen that we can implement all those assertions inside switch, if def switch, right? So by enabling that if def switch, we can control all those things, right? This inclusion for compatibility with the Axelera OVL. This inclusion is for compatibility with the Axelera OVL. Yeah, look at there, the same point they mentioned. If this macro is defined, then the assertions in the checker are compiled, otherwise they are excluded. Next, rule number 55. The inclusion of cover property statements in the checker shall be controlled by the cover on. So same thing what we have seen for assert. How we have controlled assert property by using assert on switch. Similarly here cover on. The same point, right? Okay, then rule number 56 is what? A checker shall have a category parameter to allow a category based control of its operation. Already we have seen that category, right? Category is another predefined parameter, okay, to provide category based control operation. There are system tasks that allow controlling checkers not only by their position in the hierarchy but also by their category. The category parameter is used as an attribute of the assert property cover property statements. Look at there. Okay, so we can use this category as an attribute in an assert property and cover property. Rule number 57 is a global reset signal shall be optionally specified by macro. Again, we have defined assert on and cover on by using the switch, right? Tick if def switch. Similarly, we can assert the global reset by using tick define. Look at here. This is in this example we have used tick if def, right? Switch tick if def assert global reset. If we have defined this assert global reset, then it will execute this block. Otherwise, it will execute the fail block, right? So the reset signal can be passed through a port, but also by defining the macro. This macro can refer some global signal or expression which is then used as a reset condition. In this example, if this reset is defined, then this condition when equal to 0, it will becomes the reset condition, right? This is clear. And one more thing here is the reset is taken to be the port reset underscore n of the checker. If you are not defining, then it will be taken to the port of the particular module. For example, top dot reset here. So inside the top we may use a reset. That reset will be asserted